Hello. This is a short video presentation. It has to be short because I can hardly talk, with a little more information on the factoring that we've been doing the last couple of days. First of all, the question has come up, when do we use what type of factoring? So the easiest way to answer this is to look at problems like this, 3x squared plus 31x plus 36. This is a quadratic trinomial. It's a quadratic, because, I think I spelled that right, because it's in the form of ax squared plus bx plus c. It's a trinomial because there's three terms. All right, so anytime we have a quadratic trinomial, we're going to use reverse binomial multiplication. In other words, we're going to put the parentheses here, and we're going to factor it that way. Before we factor, we haven't had to do this yet, we will, but before we factor, anytime we factor, we always want to look for the greatest common factor. This is not a trinomial, and so we're going to look at this, and all we're going to do is look for the common factor. Between the 4 and the 6, we have a common factor of 2. This is x to the 4th. This is x cubed. We have 3 x's in common. And then we end up doing reverse distribution, 2x minus 3. This is pretty straightforward. But whenever we have a trinomial, and it's a quadratic, and now there's going to be exceptions that we'll learn about later, but whenever we have a trinomial that's a quadratic, we factor it in this way. So I'm going to move this down. Now let's try to factor this. All right. First of all, we know that we need a 3x and an x. That's pretty straightforward. 36, we need the factors of 36. Well, we know 36 and 1 are factors. Now, what I'm going to do here may seem a little confusing at first. I'll do another example afterwards, but it's a pretty straightforward process. If I can divide, and I always start with small prime numbers, if I can divide 36 by 2 and multiply 1 by 2, 18 times 2 would be 36, is 36. Likewise, I can divide 18 by 9. Multiply 2 by 2, I get 4. 9 times 4 is 36. I can divide 9 by 3. I can't divide it by 2 without a remainder, but I can divide by 3. I can multiply 4 by 3. That gives me 12. 3 times 12, 36. Only thing I can divide 3 by is 3. That gives me 1. I already have that there. But I can divide 12 by 2. That gives me 6. I can multiply 3 by 2. That gives me 6. 6 times 6 is 36. Very methodical approach to finding all the factors. Now, what we want to do is decide which factors work. I'll start with the 6 and the 6. But first of all, I want to look at this polynomial. There are no common factors, nor should there ever be, if you do it right. So if I use the 6 and the 6, it's plus and plus, I see that I have a common factor of 3 and 6. If there's no common factors here, there can be no common factors here. Therefore, that is a bad choice and I can cross it off. I can't use it. Likewise, if I put the 3 here, common factor of 3. If I put the 12 here, common factor of 3. Bad choice. I'll try 18 and 2. If I put the 18 here, common factor of 3. Bad choice. But I could put the 2 here and the 18 here. Check it. 3 times 18, 54x, plus 2 times x, 2x. That's too big. Doesn't work. So, erase those. Got a little carried away there with my eraser. All right. Now, we tried all these different things, but that was kind of a wasted effort. We should have seen we have a 3 in this spot right here. I can't use 6 because it has a factor of 3. Can't use 6, factor of 3. Can't use 12, factor of 3. Can't use 3, factor of 3. Can't use 9, factor of 3. Can't use 18, factor of 3. Can't use 36, factor of 3. The only possible numbers that could go right here are 1, 2, or 4. So when you have a lot of choices, often you can reduce them. You don't have to try them all. So let's do the actual one. We're going to put the 4 here, 9 here, check it, 4x plus 27x equals 31x. So our final answer is 3x plus 4 times x plus 9. It makes the process a lot easier. All right, let's look at one more. All right, our last example, we want to factor 2x squared minus 21x plus 54. And we know that we have to have a 2x and an x. Because this is positive, these operations are either both negative, negative times negative is positive, or both positive. But because this is a negative, they both have to be negative. So now let's look at 54 and 1. Divide this by 2, 27, times this by 2, we get 2. Divide by 3, we get 9, times this by 3, we get 6. Divide 9 by 3, we get 18. Whoa. That was really thinking ahead here. Divide 9 by 3, I get 3. Multiply 6 by 3, I get 18. So this is my possible pairs that I could use. Now, let's start eliminating. Because I have a 2 here, I can't use 54 there. I can't use 2 there. I can't use 6 there. And I can't use 18 there. All these have factors of 2. The only possible choices that I can use in this spot right here is 1, 27, 9, and 3. Where do you want to start? All right. 3 and 18. 3 and 18. Minus 3x. Minus 36x. 2 times 18 is 36. Gives me minus 39. That doesn't work. Bad choice. And so I'll try 9 and 6. Let's see, what did we try? 3 and 18. Try 9 and 6. Put the 9 there, the 6 there. minus 12x minus 9x gives me minus 21x. It's what I want. So my final answer, 2x minus 9, x minus 6. But we made our life easy by eliminating, putting the 18 there, in this spot right here, the 6, the 2, and the 54. Always look for common factors that you can eliminate. All right, I hope this answers some of the questions from yesterday, and this will be our last video for a couple of days, till the end of Thanksgiving. All right, have a great day. Talk to you later.